What happens when a computer's math completely breaks down? Just imagine doing a super simple calculation, like adding 1 to the number 255, and your computer confidently spits back that the answer is 0. I mean, that sounds impossible, right? But in the digital world, this actually happens. Let's figure out exactly why. Hello, everyone, and welcome to this explainer. I am your host, and as a teacher with over 25 years of experience preparing students just like you for the Cambridge IGCSE exams, I am absolutely thrilled to guide you through today's masterclass. We are focusing squarely on syllabus objective 1.1.4. By the end of this, you'll know exactly how to add 8-bit binary integers, and you'll fully understand the really critical concept of overflow errors. Here's our game plan for today. We'll quickly review binary place values, run through the absolute core addition rules, tackle some worked examples together, figure out what on earth an overflow is, and wrap up with the most common exam mistakes you need to avoid. All right, part 1, binary place values. Let's build that foundation. Now, as you probably remember, an 8-bit register in a CPU has 8 distinct slots, split into 2 nibbles, and each slot has a very specific place value. Reading from right to left, they just double each time. 1, 2, 4, 8, 16, 32, 64, and finally 128. Here is my first big tip for you. Whenever you get a binary addition question in your exam, I want you to write these headings down on your paper immediately. Do not skip this. They are your absolute building blocks. Moving right along to part 2, the addition rules. You absolutely have to memorize these 5 rules. Now, looking at our table, think of A and B as your starting bits. C in is our carried bit coming over from the right. Sum is our final result at the bottom, and C out is what we are carrying over to the next column on the left. The first 3 rules are just like standard everyday math. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. Super easy, right? But here is where it gets distinctly digital. 1 plus 1 actually equals 10 in binary. So what do? You write down the 0 as your sum and carry the 1 to the next column on the left. And if you have a carried 1 already sitting there, you might face the dreaded 1 plus 1 plus 1. That equals 11 in binary. So for that, you write down a 1 and you carry a 1. Commit these rules to memory right now. Okay, part 3. Let's actually crunch some numbers with a few worked examples. Grab a pen and paper if you have one handy. Before we start doing the math, you must follow these 3 steps for every single exam question. Step 1, align your columns perfectly. I've seen it a million times. Messy handwriting loses marks. Step 2, always add from right to left, just like you would in normal binary addition. And step 3, be meticulously careful about carrying your 1s to the next column. Let's look at an example step by step. Value 1 is 39 and value 2 is 74. Starting way over on the far right column, 1 plus 0 is 1. Moving 1 step left, 1 plus 1 is 0, and we carry the 1. Next up, we have 1 plus 0 plus our carried 1, which gives us 0, and we carry the 1 again. We just keep moving left like this, applying our rules really carefully. Our final sum values give us 0, 1, 1, 1, 0, 0, 0, 1. If we convert that back, it's 113 in denary, which is exactly what 39 plus 74 should be. Now let's level up the difficulty. Here we're adding 126 and 62. Notice what happens here with our consecutive carries. Right to left, 0 plus 0 is 0. Then, 1 plus 1 is 0, carry the 1. But look at the next 4 columns. They literally all result in 1 plus a carried 1. That means you write a 1 and carry a 1, over and over and over. You have to be so careful here. Dropping a carried 1 is the easiest way to lose a mark on the exam. Our final 8-bit answer here is 10111100, which perfectly equals 188. Section 4, Understanding Overflow. This is where standard math suddenly hits a digital brick wall. I need you to burn this number into your mind for the exam, 255. If you turn on all 8 bits in an 8-bit register, meaning you add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, they add up to exactly 255. That is literally the absolute maximum denary value that an 8-bit register can possibly hold. It cannot hold 256. So, what exactly happens if a calculation goes over that limit? Well, we get an overflow error. The Cambridge syllabus defines this exactly as a type of error that occurs when a number larger than a register can store is generated, meaning a value outside the predefined limit is returned. If the exam ever asks you for a definition, write this exactly as it is to secure full marks.
Let's see an overflow in action. We are adding 011,01110, which is 110, to 1101110, which is 222. When we carry out our binary addition moving right to left, everything seems perfectly fine until we get all the way to the 8th column on the far left. We end up with a 1 plus 1. That gives us a 0 and forces us to carry a 1 into a 9th column. But wait, our system only has 8 bits.
This is the visual reality of an overflow. On the left, we have our rigid 8-bit register with a max capacity of 255. On the right, our calculation naturally resulted in 332, which physically requires 9 bits to exist. The CPU literally has nowhere to store that extra 9th bit, that leftmost one. So it just drops it. It vanishes. The remaining 8 bits evaluate to just 76. The computer has lost data and returned a completely incorrect answer simply because the hardware capacity was exceeded. Let's move to our final phase, Section 5, Common Exam Mistakes. Let's make sure you secure every single mark. Listen closely because these are the major pitfalls I see students make year after year under exam pressure. First up, forgetting to carry the 1. Always write your carries clearly above or below the columns so the examiner can actually see you're working. Second, writing a 9-bit answer when the question explicitly states it is an 8-bit register. If there's an overflow, you must explain that an overflow occurred. Do not just cram 9 bits onto the answer line. Third, giving a vague explanation of overflow. Use the precise terminology we just went over. And lastly, rushing and messing up your basic denary to binary conversions. Take a breath and take your time.
And here is my ultimate time-saving pro tip for you. Always check your binary addition by converting the numbers back to denary. Basic decimal math is the best way to verify your binary answers. If your decimal addition perfectly matches your binary addition, you can confidently bank those marks and move straight on to the next question.
All right, now I want you to try this yourself. Let's wrap up this masterclass by challenging you to solve a classic 2-mark Cambridge question. Calculate 8 ones plus 1 in an 8-bit register. What happens and why? Think back to our very first slide. 8 ones is 255. If you add 1, you end up carrying 1s all the way across, resulting in 8 zeros and a 9th bit of 1. But because it's an 8-bit register, that 9th bit is completely dropped. The result becomes 0, and an overfall error occurs because the value exceeded the maximum limit of 255. See how that all comes together? Master this, and you are incredibly well prepared for your exam. To help you lock this all in, be sure to seek out more practice questions, easy, medium, and hard ones, and keep testing yourself on those core rules. Keep practicing, stay confident, and I will see you in the next explainer.